Hi, in this video I will walk you through the core features of the Blocktrust workflow platform and the common use cases. We are going to first create a decentralized identifier which we will use for issuing. Second, issue a W3C verifiable credential based on a form submission and verify a credential in an automated workflow. Along the way, I will explain why each step matters and how it connects to the underlying decentralized identity standards, especially DID's verifiable credentials and the DID Prism method on Cardano. Let's begin with the DID creation. The foundation of everything in the SSI ecosystem is the DID, a decentralized identifier. In the Cardano ecosystem, we are using the DID Prism method, which is anchored on the Cardano blockchain. To create one and to store one on the blockchain, you basically have two choices. Either the Hyperledger Identistack, which uses the cloud agent, or much simpler, the OpenPrism node, short OPN. We will be using the OPN. If you are not already familiar with that, have a short look at the related documentation or GitHub repository of the OPN. In any case, for our walkthrough, you won't be needing it, as we provide all the information to you, at least to create a DID on the pre-prod network without any further setup. To create a DID, we first need access to an OPN instance and a wallet on the Cardano network. You can self-host the OPN, but for this demo, we use the hosted preprod instance from Blocktrust at opn.preprod.blocktrust.dev. Once we have the OPN URL and the wallet ID, which you can find in the documentation for easy copy and paste, we head into the platform and configure the DID registrar settings. These settings are reusable across workflows and save us from having to paste connection details every time. Now, let's start out with our first workflow to create a DID. We will create a workflow with a manual trigger so we can run it on demand. Then we add the create DID action. If we configure the registrar settings, we can just select use tenant settings. Otherwise, we can enter the OPN URL and wallet ID manually. Next, we set up the verification method. This tells the system what kind of key to generate and what it will be used for. For this example, let's call the key ID key1, and for the purpose, select assertion method, because we will use this key later to sign a verifiable credential. For the curves, select SECP256K1, which is widely supported and the default in this platform. We also add a linked domain service to the DID document. This is purely optional but helpful when associating the DID with, for example, a public web domain. Just for demo purposes, we use the page of the documentation here. So, for example, docs.workflow.blocktrust.dev. Once that's saved, we rename the workflow to something like create DID workflow, and then we execute it. Behind the scenes, the workflow communicates with the OPN and publishes the DID to the Cardano blockchain. In detail, this means that the workflow is calling an endpoint on the OPN called the Universal Registrar API, with not only the specification on how the DID should look like, but also the wallet ID, which refers to a Cardano wallet hosted by the OPN so that we can pay for the transaction. Since we set up the OPN registrar for the pre-prod network, This will be using a wallet with testnet tokens. Switching to the mainnet would be as simple as using the mainnet OPN in a wallet with real ADA. The OPN then creates a new DIT, the keys, and writes it to chain. Then it monitors the chain and returns a resolution document, including the private keys, back to the workflow platform. But since we executed it, now we can have a look at the logs. The workflow returns a new DIT document, and very important, a secret section in there that includes the private keys. These are critical. The master key is used for updating and deactivating the DIT. So if you have an update DIT or a deactivate DIT action in the workflow, you will need the master key to prove that you are owning this DIT and you are allowed to do the update. The private key of the assertion method is used to sign a verifiable credential. The public key is split here into an X and Y coordinate, often called the uncompressed format. And the private key is D. That's all base 64 encoded. We are basically done with the creation of the DIT here. The workflow platform serves as a simple UI for the OPN. It's basically a one-click solution to create a DIT on chain now. But since we want to do more with the DIT, let's register the issuing key inside the Blocktrust platform. This is done under the tenant settings, in particular the issuing key settings in the profile section. So we enter a name for the key, the DIT we just created, the key type, the two parts of the public key, and the private key. This issuing key will later then be used to assign verifiable credentials following the W3C standard. So that's finally wraps up the DIT creation. Let's continue with the next part. Let's imagine a scenario. The student completes a course and submits a form to receive a digital certificate. We want to turn that form submission into a signed, verifiable credential, like a digital diploma. We start building a new workflow and choose the form trigger this time. This creates a simple form a user can fill out. We add 4 fields: name, DIT, email, and secret code. The DIT field ensures the credential is issued to the right identity. And the secret code lets us validate the request. Now let's add a custom validation action next. This is where we define logic to verify that the entered code matches one of our pre-approved values. Say something which was given to a student individually to block unauthorized credential issuing. For the next action, we actually issue the W3C credential. This is where the real magic happens. The subject DIT, so in our example, the DIT of the student, we will take from the form field. The issuer DIT is the one we created earlier and set up in the tenant settings. The claims is basically like the user's name and maybe the degree someone earned. For the expiration date, we set it to 1 year from now, but you can choose whatever you like here. And the expiration date is also optional. So this action, when executed, returns a JWT-based verifiable credential signed with our issuing key. Finally, we want to get the credential to the recipient. We use the email action to send it to the email address from the form and include the credential in the email body using templating variables. In a real-world scenario, you might even would use didcom v2, which is also supported to send the credential directly to the wallet of a user. That's it. We save, publish, and test. We grab the form URL from the form trigger, open it, and can fill out the form. After submitting the form, the user will receive a credential as a signed WT in their inbox. Let's quickly ensure that we indeed get the email. Here it is with the credential inside. For the last part, we asked the question how to verify a credential. Let's assume we are the developers of some web service and someone sends us a credential, either by a form or by a wallet interaction with our application. How do we verify that? We create a workflow for this, of course, and this time we start with an HTTP request trigger, meaning that the workflow will be triggered if the developer's application sent a request to the workflow endpoint. So we will set up the workflow to receive an HTTP post request with a particular format. Next, we add the verify W3 credential action. It checks that the credential we received has a valid digital signature and it isn't expired and it isn't revoked if that is supported by the credential, of course. For the digital signature, in background, the workflow platform calls into the OPN and resolves the DID, which is defined as the issuer inside the verifiable credential. Resolving means getting the DID document that matches this DID using the OPN endpoint for the universal resolver. This contains the public keys, and with those public keys it is possible to verify the signature of the credential. The output of the action is basically a Boolean result. True if the credential is valid, otherwise the workflow would stop. But we have to take it one step further with the W3C validation action. This allows deeper checks on the credential structure and content, since it is not enough that the credential itself is valid. There could be arbitrary content in the credential. We need to ensure that the credential is issued by a specific DID. In this case, of course, the DID that we created earlier as the issuer did. Next, we might want to require certain values. In our case, for example, the name. We also want to require that we have a certain string in there. For example, the name of the degree. These rules together ensure not only that the credential is valid, but also that it means what we think it means. Finally, we use an HTTP action to send the verification result as well as the validation details to another server. We first send the credential to our workflow and then get it immediately sent back to us with the validation result, without touching any SSI concepts and the deeper logic behind DID resolution, credential verification, etc. The workflow platform makes the issuing and the entire verification process automated and accessible. This wraps up the guide. To continue further, have a look at the different templates and the documentation. Have fun!